Hello everyone, welcome to InfluxDays. I am Balaji and I manage the product team at InfluxData. I hope you're enjoying all the wonderful content we put together for you during this InfluxDays. In this session, I'm going to take you on a journey into our InfluxDB tasks, which could be a developer's best friend since they would make the platform do a lot of heavy work for you. In the next 15 minutes, we will go beyond the mumbo jumbo of task being a Flux script and really show you with examples on how to go about building a task. Then we'll take a look about a feature we introduced recently called Invokable Scripts and how tasks can be made repeatable using the power of invokable scripts. And we'll also paint a picture on where we are headed into the future. So let me take a step back first and give you an overview of what is a task, right? Simply put, an InfluxDB task is a segment of code, right now it's a Flux script, that can be programmed to run at scheduled intervals. So they can really help you see as a developer to automate a lot of the repeatable work that needs to be done on your time series data. As an example, if you're, let's say, in an industrial IoT or IoT use case, you may have sensors out at the edges. Sensors may be powerful or maybe, it doesn't have a lot of CPU memory, so they may only emit some data points. So the raw data that comes in may need to be transformed into something effective, essential, that you need to gain insights out of. Perhaps you're showing this, if you're into the power sector in a smart meter, you're collecting watts that needs to be transferred or translated into kilowatts, or maybe you have to show the billing to your end users and so on. If you're in the monitoring or observability platform or area, your data may be emitted every 10 or 15 seconds. And that's useful information when investigating an issue. But showing a longer time frame, you only need to see summaries or trending and so on. So you may need to downsample. We call this downsampling. So you take the high frequency data and then take an aggregate like mean, sum, count, and so on. And then basically you reduce the number of data points you have in a particular time frame. That's called as downsampling, and tasks are very effective for that. So in all of these use cases, your code or script may be programmed to query from the raw data bucket, as you see in the picture, right? So you apply the right transformation. Again, Flux is great with that, or an aggregate function, and then write to another bucket. And just be sure to create that bucket beforehand, because in InfluxDB, that code segment will error out, right? So it's just very simple to do this downsampling or even transformation, where you take from a bucket and transform it and write to another bucket. So with that introduction, let's dive into an example of how you would go about building a task. All right, so let's take an example here, right? So this shows you how you would go about building your first task. Now you must be wondering, what is this mumbo jumbo, right, on the right? This is Flux. If you're totally new to Flux, it's okay. You can simply think about Flux as a query language. But Flux is more than a query language. Flux is a functional data scripting language. That is, it can do a lot more than just query. You can apply transformation logic, of course, but also you can take actions on it. You can call an HTTP post as an example that allows you to do a lot of wonderful things. Like, it allows you to extract the insights and then call an orchestration flow outside of InfluxDB. It's really powerful from that, if you look at it from that perspective. Again, these could be HTTP posts, but we also support a whole number of endpoints, which you will see later on in the slides. Anyway, let's just focus on querying aspect of Flux, right? With these 3 lines, you're asking your Flux code to get the time series data. For example, when you see from bucket, it just tells you that, okay, you got to go get my data from that bucket called raw data. And the next line says, by the way, that's a pipe forward operator. What's a pipe forward operator is you tell Flux to take the results of the previous code segment and then feed it to the next function in that line. And here, essentially, what you're saying is restrict your query to only last 15 minutes. And then once you see Flux is going to get that data, and then you're saying, hey, filter it to this measurement and this field. All of this happens in a very easy and kind of straightforward, streamlined way. Flux does this for you. It does the optimization, push downs into storage, really in a performant way so that you're getting the results really fast. Let's take a look at how you would do the next thing, right? So you got some data. Now you want to apply the transformation, which is in this case a mean on the value column. What it does is you might have in the last 15 minutes thousands of data points. You're saying do a mean, and Flux will basically take that thousands of data points, reduce it to a single data point per measurement field and tag CD's key, what we call a CD's key. And then that's kind of your single line of row of data that you get. This computation only happens in the query container right now. And so at this point, you can actually put a dashboard cell, and that will reflect you can visualize that data point, right? If it's a single data point, you'll see that, or it might be a series of data points depending on whether you have a series or not. So let's take a look at the next example. Okay, so now you only, basically, as I said, you're only visualizing it. With this one, you're saying, okay, I want to persist it to a different bucket. In this case, you're saying, take all of those mean results and persist it to a different bucket called downsample data. What we did so far is we took the data from raw data and looked back 15 minutes, calculated the aggregate, which is the mean, and then wrote to a different bucket, which is the downsample data. So how do we tell the platform to run it every 15 minutes? Basically, you want it to be automated, right? So this is also very easy. So here, in this case, you're saying, save this as a task. As part of that, you're giving the task a name, and then you're saying how frequently to run it. In this case, it's 15 minutes. And the offset parameter just helps you to introduce some delay. You might have a lot of tasks running every 15 minutes, so you might want to space them out or introduce some jitter so that they don't run all the same time. Right, so here's another example of a custom downsampling task. We saw a simple example. Flux can do so much more. Here in this example, you're basically, Flux is getting an aggregate from one of the buckets, and it's also getting an aggregate from a different bucket, and then you're joining the two. We have a join function. Again, this is where the power of Flux comes in. Not many query languages can really join from two different data sets, right? So another important point here is Flux can allow you to join a time series or time-based data set. You can also query from an outside system, external data source like a SQL, Postgres, MySQL. You can get perhaps the metadata and then join them together. So you can do a lot of wonderful stuff. There are other ways of downsampling data as well. There are more examples of this that you could check out our Meet the Developer video series in our YouTube channel. Okay, so task system goes even beyond the downsampling task, right? So for example, you might want to tell, in Flux, you might want to just look out for certain patterns in your data. We call this alert checks, but they're exactly built on top of the same awesome task platform. So in this case, you can create a check. We call it check, but actually it's a task running in the back end. It looks at the monitor data bucket in this case, and then you can also say, hey, look at this measurement, this field. You can also introduce a lot of conditions there. You can transform that data. And then finally, you can apply a threshold condition. You can say, if this exceeds a certain threshold, or if it goes below a certain threshold, then create an event in the system bucket. The underscore monitoring is a system bucket. Basically, we provided in the platform specifically for this purpose. And you can't delete it. It doesn't count your buckets count. So it's really great. And it just collects all those events that you send from the monitored checks, alert checks that you create. You can also go beyond just looking for threshold-based conditions. You can perhaps look at deadman alert. Deadman is basically saying, watch my data stream, and if something is not coming in at the frequency you specify, then basically trigger an event. Very useful. You might want to, you don't want to look at it, and you don't want to disrupt your end users when they're looking at the visualization, or you're looking for alerts based on this, so you need the data stream to constantly come in. So there are deadman checks available for that as well. So this is an example of a deadman check, right? So what's important here to know is that, again, the option task, that the name of that, it tells you how frequently that deadman check is really running. And you can see the bottom 3 lines that says, hey, run this every minute, but basically look back last 5 minutes and then see if your data is incoming. You're basically telling it, saying that look for 5 minutes, but run every minute, and if data is not appearing, then create an event in the underscore monitoring bucket. At this point, you can actually create a dashboard visual. So if you want, you can notify, but you can also do a simple dashboard visual that will just read the underscore monitoring bucket and pop up things in red. You can look for critical events and show it in red, or if there is a warning event, you can show it in yellow, and so on and so forth. Really powerful if you just want to visualize that data. But you might want to go beyond that, right? So if you want to go beyond that, basically, this is our notification system, right? So here's where, based on the incoming checks that events that you have, you might want to notify somebody. Notification is also built on top of the task system. So in a way, it works exactly like the alert checks, but here it's a reverse, right? So now you're watching your underscore monitoring bucket. Remember, we pushed some events into that, and now based on the events, you're going to trigger a notification. You might be wondering why you need 2 separate, kind of tasks for that. Well, you could also set up notification right when you determine that there's a condition triggered. That's also okay. But in this case, sometimes you don't want the alert storms, right? So you don't want to keep notifying people, or maybe there's a blip or there's a spike. You might want to say, okay, look for 3 out of 5. If in the past 5 minutes, if there are 3 events out of 5 events that happened, then notify. Or you might have a more detailed condition like, if this is a warn, then send it to Slack channel. If this is a critical, page somebody. So you can get to that sort of granularity with the notification system. Additionally, notifications also allow you to send your notification to an endpoint, right? So we talked about Slack, PagerDuty. You can also send it to Microsoft Teams, or you can do a HTTP post, which could be used to trigger a custom orchestration workflow. Very powerful in that perspective, and we believe that this is the key differentiator that makes InfluxDB really one of its kind. This is an example of a notification task. Again, very similar to what you saw in the alert check task. In this case, you can see the notification looking back 2 minutes and seeing if there are any deadman checks, and triggering a Slack message with the color coding. If the Slack message comes in, if there are critical events, you want to send it as danger, so you kind of color code that as dangerous. I'm going to switch topics a little bit here, switch gears, and next I'm going to introduce a recent feature or capability we added to the task system, invokable scripts, and how it instantly adds value to task. So what is an API invokable script? You should think about API invokable script as a serverless function, like an AWS Lambda. There's some important differences. For example, you wrote a custom downsampling logic to address when you onboard your first customer, right? Your first customer comes in, and you are getting data for that customer. You're trying to transform that. You wrote in the transformation logic. You're pushing it to a particular bucket for your first customer. Your second customer, when they come in, you create a new bucket, and you see that it's the same logic. Maybe you change some things here and there. You insert new values, or perhaps you're looking at different kind of thresholds if you're using alerts. But essentially, it's the same logic. So what you could do is you can save your logic, the entire transformation logic, as a script. And when you do that, you can also say, hey, there's certain parameters. You might want to parameterize certain things that you want to send in values at one time. So what happens is now this powerful feature, that is the API invokable script, allows you to be invoked, and at invocation runtime, you can send specific values that acts as the same way, like for customer X, for customer Y, and so on. Really, really powerful from that perspective. The other thing about invocable scripts is these are invocable remotely. They come with an API endpoint, and so what that API endpoint allows you to do is you can call from perhaps AWS Lambda or Node-RED or some other external system. So you can really see the power of this, that you can remotely invoke a particular script, and perhaps you can activate certain logic that you may want to trigger from outside. You can simply think about it as a trigger, right? So there's an external event, you can do that. You can also, for example, this allows you to get a set of users who want to use that API for some other reasons. They can't build Flux and so on and so forth, but you can really help them invoke that API, send in particular values, and get that results. Really powerful from that perspective. So what about tasks, leveraging in scripts, right? So now you can use these invocable scripts to save once and create your task by invoking the script and passing the parameter you need. As an example, you can create a custom alert check that notifies different teams based on the measurement or field or bucket and pass those parameters at task runtime. The benefits are really, really enormous in terms of code reusability. You can have 1 to 2 people on your team build your tasks because they need to learn Flux, and then alerts. And their other team members can simply use those API scripts and pass those respective parameters like a completely a black box, right? So you can just call those functions and pass certain parameters, and they could leverage it to create their own task or their own alerts and so on. Since I'm in product management, I want to paint a little bit of the vision that we have for tasks in InfluxDB, right? So let's take a look. So we believe that InfluxDB platform is really unique in not only allowing users to store, transform, and analyze time series metrics, events, but also take action based on the patterns you observe in the data. You can go beyond analyzing and visualizing and actually acting on that insight you get. For example, we saw that you can actually schedule a task and automate any repeatable work you have. Right? With API scripts, you can also invoke them remotely. Imagine, let me give you an example. Imagine that you have a factory floor, right? And so you have a machine which has not been sending data for weeks at a time. When this machine is started up, all of a sudden it's going to send in all of that data that it's been locally keeping for the past 2 to 3 weeks. When the data is arriving, your current tasks have already moved on there at your current setting, right? They are not going to go back and re-aggregate or retransform all of the 2 to 3 week data that has been coming from this machine. What you could do is create a specific script that could be invoked remotely, and you can send in parameters and that can specifically act on your data that has been arriving late for the past 2 weeks and so on. So without touching your current ongoing tasks that you may have. Great. What else do we have? In the middle, you see that we have a scripting language. We support Flux today. Flux is awesome at a lot of things, but you may want to code something that you've been programming from your birth, for example, like JavaScript or Python. So we plan to add these so you can not only run Flux scripts or Flux tasks, you can also run a Python or JavaScript task and really act on your data. So you don't need to learn a new language and so on. On the right, you have 3 different destinations. We support all of them, right? So you can either send your data to a bucket. Again, the bucket could be local in your organization, or you can send your data into a remote bucket that perhaps you have a global application. You want to show your users globally what's happening. So you might synchronize your data from one of the buckets here to another bucket in a region. There's another aspect here, right? So maybe you have edge situations, edge devices, and maybe you're using InfluxDB open source at your edge. What tasks allow you to do? You downsample your data at your edges. So if you really want to look at edge like in a high frequency, high granularity, you can do that. But you can also downsample it, and using edge data replication, you can send those downsampled data into cloud. Really powerful. I think if you want to know more, check out the session from Barbara. She talks about not only edge data replication, but all of the other new things that we have introduced in InfluxDB. And let's talk about other destinations, right? So you can send in into a notification endpoint. You can, we saw Slack, PagerDuty as notification endpoints. There are a whole bunch of other endpoints we can continue to add to our roadmap. There's also, you can send it to a big table, for example, or Snowflake, because again, data doesn't exist in isolation. You might want to put that data into another BI solution and bring together with other data sets and so on. Really, InfluxDB allows this to really happen. So as you saw, we can do a lot of things, automate a lot of the repeatable things that you may want to do. And why not, right? So let the platform do all the heavy lifting for you, and you sit back, relax, and have a cup of coffee. So thank you for listening to my talk. Please be sure to check out some of the other videos, and also don't miss the demo from Vinay. He's going to, whatever I showed in my slides, he's going to really take you into the depth with that demo. Please check out that session, and thanks again for watching.